hooked up, but we do have them wired in to a test bed so we can check out a few things. The boards that we have are getting hot. They're running about 130 degrees. So I've made some modifications. I've added some jumpers to the back of these, and we're going to go ahead and test these today. The problem we were seeing is that after about 5 minutes of runtime, the temperature on the board is about 130, like I said, and they didn't make the copper traces thick enough. The other thing that we've had is we got some Dell power supplies. We got actually two versions of the power supply. Both of these are DPS 750. One of them is made by HP. The other one is made by Dell, or branded Dell and HP. They're both made by Delta Electronics. So the boards that we ordered were supposed to work with both. There's a little switch here. I don't know if you can zoom in and get a good focus on that. There's a little switch here. This side is supposed to be HP. Right here is supposed to be Dell. And right here is supposed to be off. So there is a solder pad that's underneath this edge connector that was not populated. So I just pulled enough of these edge connectors off, populated the solder pad, and put all the edge connectors back on for all the power supplies right here. Problem 1 and problem 2. So let's check some temperatures. On a 1200 watt HP power supply, 1200 watts going through that board, and we're running, depending on where I hit it, anywhere from 135 to 141. Now these are the same boards, but they're only on a 750 watt power supply, and we're only running 94 degrees. So a big plus for using the 750 watts is, one, we spread the load across two boards, and it actually gives us 1500 usable watts instead of the 1200 that we get from the HPs. You know, other than that, compared to we don't have any of them here in this mine, but we got some in our one in Morgan City. The 2400, DPS 2400s. But, you know, this board's going to have the same issue no matter what power supply you put it on if you're pulling 1200 watts. So, alright, we're going to go ahead and swap out the power supply, or swap out the board, and let this one warm up a little bit. And we'll bring you back in after we got the board warmed up and we're ready to check the temperature. Alright, so we've been running for, I don't know, 3 minutes or so. It usually takes 3 to 5 minutes for it to warm up. And let's check the temperature on the modified board versus the original board. So the modified board's running about 98. You got it good?
There we go.
Alright, the modified board's running 98 to 100. The miner's now at full hashing power. This is at the point, I mean, if we can get a shot of this one right next to it.
Yeah, I got a good shot.
Yeah, so we're 130 degrees. And we're just going to have to modify each one of those boards. What I'm going to end up doing is drawing a board myself and sending the Gerber files over to our friends in China and have it printed. But we're probably going to triple, if not quadruple, the thickness of the copper that's on the board. Another thing that we've learned is the rating for the wire, the amperage on wire from the NEC is probably not the best whenever you're doing continuous loading. I'm going to reach over here and grab an NEC reference, actually an Uglies book. So we're using this 75C column right here because all of our connectors and fittings are rated at 75C. So we should be able to do 50 amps on a number 8 wire. So we have, each shelf has 8 miners on it, and that's going to one piece of number 8 wire. It's marine grade we're in test mode, the panels aren't lined up right. I was putting miners in yesterday while Logan was wiring electrical. So on the jacket, we're running 96 degrees on the jacket. I mean, it's 82 in here. So this unit right here, this wire has 41 amps coming over it. I got a total of 80 being drawn off this panel. Now these conductors, this is aluminum wire. We oversized it. This is only 200 amps going to this panel. We sized this for 240 amps. And those wires are room temperature. So we'll probably be